Hi guys, welcome to Foam Dude. In this video, we are going to see how to use BlockMesh in OpenFOAM. BlockMesh is a utility that ships standard with OpenFOAM that allows you to create simple meshes in rectangular shape particularly. You can stack different rectangular shapes or rectangular meshes on top of each other to create more complex meshes that your applications demand. A lot of times it serves as your starting point for more complex meshing tools such as SnappyXMesh. So let's look at how BlockMesh works. We are going to start by copying one of the tutorial cases and start looking at the BlockMeshdict file, and we will see how to use BlockMesh in the next several minutes. So I'm going to start by copying one of the tutorials from incompressible cases for icofoam, and we are going to grab the cavity case. I'm going to put it in the parent directory. So we are going to go in the cavity case, and you will see, like we discussed in the previous videos, for the basic case setup you should have 0 constant in system. The block mesh is set up through a directory called a block mesh is set up through a dictionary called BlockMeshdict, and it can be found under system. So if you look under system, you should see a file called BlockMeshdict. So let's open this BlockMeshdict file. As you can see, it has the same header that all OpenFOAM files have, and then it starts with some vertices, some blocks, and definition of the boundaries. So let's look at the vertices. So as you can see, your vertex number 0 is 0, 0, 0. Vertex number 1 is 1, 0, 0, and so on and so forth. So the question is, how do you create these vertices, or how do you decide the order in which you have to create the vertices? It really depends on how you want to order these vertices in the blocks that you see here. To further understand how the block orientation is handled in OpenFOAM, just go to the Google and search something like OpenFOAM block mesh and pick up the first link that you see. In this block mesh user guide, you're going to find the order in which you need to specify the points in a given block. So let's scroll down and look at the schematic that they have shown here. So as you can see, the order of the points in anti-clockwise direction is 0, 1, 2, 3 form the bottom face of your block. 4, 5, 6, 7 forms the top face of the block. So you're going to create a block from these 8 vertices by joining in a particular order. So if you start with an anti-clockwise order, then you have to stick to the anti-clockwise order. So you will specify the block definition as 0, 1, 2, 3, 4, 5, 6, 7. Alternately, you can specify in the clockwise fashion where you can go 0, 3, 2, 1, 4, 7, 6, 5. You can also specify the block with respect to a different orientation, such as 0, 1, 5, 4, and 3, 2, 6, 7. As long as you hold the same convention, clockwise or anti-clockwise, and you specify 2 surfaces that are parallel, you should be fine. So let's look at the block mesh that we have opened up, the BlockMeshdict file that we have opened. You can see in the case that we are dealing with, or in the BlockMeshdict that we are dealing with, our order is 0, 1, 2, 3, 4, 5, 6, 7. So that's pretty self-explanatory. The next part is how to join those vertices, and that's where this blocks entry comes into picture. So we are going to create blocks from the vertices in this order, the order that we already talked about. The next entry is the grading in X, Y, and Z direction. So you see we have 20 elements in X, 20 elements in Y, and 1 element in Z. And the next part is simple grading. So you can have graded mesh in one or more directions. The grading can be specified to the vector that follows this word simple grading. There are multiple ways to grade your mesh. You can find more details in this user manual for block mesh. So at this point, you have created blocks. The question comes, how do you name the boundary faces? That can be handled through this entry in your dictionary called boundary. And this is where you're going to say which face corresponds to which name and what's the boundary type. The definition of the type is optional. You can get away with not specifying the boundary type. So, for instance, if I comment this, it doesn't really affect the functionality of BlockMesh. It will still generate the mesh, but it by default assigns boundary type patch to every unspecified boundary types. You can then go to constant polymesh boundary and specify your boundary type later once you progress further in your case setup. So in this case, we are going to keep it as is. So we are going to say the moving wall is the wall formed with vertices 3, 7, 6, 2. So on the figure on your left, that wall is going to be 3, 7, 6, 2, as you can see here. And we are going to assign the boundary type wall. You can follow rest of the faces from this file, and that should be pretty self-explanatory as to how we are assigning different faces of your mesh to a particular boundary name. You can see there's an interesting boundary type here. It's called type empty. Type empty means it's not going to solve in direction along the empty planes. So let's look at this empty plane. So we are saying that the boundaries under 0, 3, 2, 1 and 4, 5, 6, 7, which are the bottom and the top files, bottom and the top faces, which we are also going to call in this case as front and back, are going to be assigned as empty. That means there is no flow taking place across these boundaries, or there is no heat flux across these two boundaries. So it's a simple way of saying that our problem is in fact a 2D problem and it's not really a 3D problem. In many of the cases, you may or may not have this empty type boundary condition. If your problem is 2D, then you will either have empty or you will have wedge, which corresponds to your axisymmetric boundary. But for all 3D problems, you will not have this empty type boundary condition. So assuming you have already edited this BlockMeshdict file based on the dimensions that you want to model, uh, you can you can save it and close your BlockMeshdict. Remember, BlockMeshdict will always sit under system directory. Earlier, it used to sit in a constant directory, but now with the newer versions of OpenFOAM, it sits under the system directory. So you can generate your mesh by typing in BlockMesh on the command line, and you will see some information about what has happened in execution of BlockMesh. So you can see it is grabbing your information from system BlockMeshdict. It has created some topology. It has created a certain bounding box. You can see the definition of your bounding box. You can see some quick statistics about what's inside your mesh. We have 400 cells. In our mesh, we have 882 points. And we can also see that there are different patches that were assigned. If you were to see what the mesh looks like, we can simply type in parafoam, and then we should be able to see the mesh. You can change the representation to surface with edges and you will be able to see the mesh. So that's it for now. Stay tuned for the next.